Dear pupils, welcome back. We are going to be doing today some reckless geometry, okay? Geometry that falls out of the contents, of the official contents, let's say, of given by the government on its syllabus for years 10 and 11, 14, 15, 16 years old. Okay, nonetheless, this is important and this is useful. What are we going to be doing? We're going to be speaking about surfaces, let's say, dimensions. Why? Because we have this classical definition that I have already given in one of my videos for lines, surfaces, and volumes as the result of first connecting points by means of lines, okay, then connecting lines, for instance, like this, or just connecting 4 straight lines in order to make a square, with the idea of connecting lines to define interiors and exteriors in the plane and to call the interior area. Okay, an area or a surface. Okay, this is area. We define an interior and an exterior, and we call the interior in the plane, we call it surface. And the same idea, we can connect surfaces in order to define interiors and exteriors in the space, and we call the interior volume. The idea would be, the simplest idea of this progression of connections would be 2 points connected in order to make a line, a straight line, with several straight lines, a square, and with several squares, then a cube. Okay, that's the idea. But this definition I gave introduces the idea of as synonyms, lines, 1 dimension, 1 degree of freedom, surfaces, 2 dimensions, 2 degrees of freedom, and volumes, 3 dimensions, 3 degrees of freedom. And being it true, it's not so intuitive, okay? Because at the end, on the spherical surface, I move with 2 degrees of freedom because it's a surface, okay, by definition. But it sounds a bit weird because as I move on the spherical surface, I change my horizontal, vertical, and depth positioning as I move, okay? Horizontal, vertical, and depth positioning. And as I move, I am changing those 3. So 2 degrees of freedom or 3? Okay, so that's why I decided to make this video, to strengthen some weakness that this definition has. And for strengthening it, okay, we're going to be seeing what coordinates are, what dimensions actually are, what degrees of freedom are. We're going to be speaking about connecting surfaces by means of curving things, okay, and like that from a rectangle we could get more or less a cylinder. Now we are going to be seeing that some surfaces, we can do that with some surfaces, and they are developable surfaces, that we can't do that with other surfaces, like the spherical surface, and those are called non-developable. And what else? Yes, I think we are going to be speaking about thickness in order to introduce surface as something without thickness. And we are going to be speaking a little bit about analytical geometry and differential geometry as a consequence of the development of the ideas of dimensions and the ideas of thickness. And finally, we are going to be speaking a little bit about cartography, because the idea of not being able to flatten a spherical surface, the fact of the spherical surface not being a developable surface, is the problem cartographers face when they try to represent something spherical, as the Earth is, into a flat surface as a map is, okay? And that's the underlying reason of being the relative sizes of Australia and Greenland in an Earth globe very different of the relative sizes of Australia and Greenland on a map. If you don't believe me, you just have to go and look to an Earth globe and look to a map, see if the sizes of Australia and Greenland look to have a relation of maybe 2 here, and you will be seeing that in the map have something completely different or quite different. Okay? And with all this in mind, some important things as coordinates, degrees of freedom, curvature, we are in a very good position to tackle the idea of space-time. Why not? Why not? If you are prepared to speak about the space-time, why not speak a little bit about the space-time, okay? Because if we know now what dimensions are, we could forget a little bit about the reality we see with our eyes, and we can start to think of things of 1, 2, 3, but also things of 4, 5, 6 dimensions. And if we are curving a rectangle into a cylinder and making something flat, something two-dimensional, making it the envelopment of something three-dimensional, making a cylinder, why not are we going to be able to curve, if we curve something of 2 dimensions into the 3D space, why are not we going to be able to curve something of 4 dimensions, as space-time is, into something of 5 dimensions? Is that interesting? It is not. We are going to be seeing a lot of interesting things there. I am not going to unveil more, let's say. And finally, we're going to be speaking about the pleasure of finding things out. For me, it's a pleasure to teach you. And for you, it should be a pleasure to learn. Maybe not thanks to me, maybe not thanks to your teacher, maybe just because of your own work. But there is pleasure on study, of course, and you have to find it, because if not, we are going to be suffering all day long. And is there a pleasure on studying? Of course. Of course, because and this happens with crosswords, with riddles, and so on. Okay, why is there a pleasure on finding things out and on studying maths? Okay, because at the end of the day, maths are problems, and life is full of problems. And Mother Nature wired our brains in such a way that whenever we solve a problem, dopamine. Dopamine. That's why we find pleasure on riddles. That's why we find pleasure on solving crosswords, because our brain, for some mysterious reason, in fact, evolutive reasons, is wired like that. Solve a problem, dopamine. So let's speak a little bit about it in order to help you find pleasure on study. And with further ado, let's work a little bit with the idea of degrees of freedom. What are we going to do to learn what degrees of freedom are? First thing, we are going to have an intuitive approach to degrees of freedom. Okay, what do we think degrees of freedom are? Then we are going to introduce coordinates. We are going to introduce coordinates, rectangular coordinates in this case, and with the help of coordinates, we are going to be giving mathematical definition, more rigorous definition of degrees of freedom, okay? That is going to, of course, match, let's say, with the intuitive idea of degrees of freedom we are going to be developing right now. Okay, so degrees of freedom. What do we think degrees of freedom are? I don't know, it's something like to be able to move. Okay, I want you to reflect with me on the following idea. We have this line in between my fingers, okay? On this line, we say normally that we can say that we move with 1 degree of freedom. If you don't understand what I mean by that, I could tell you, or I will tell you that I mean that we can just move backwards and forwards on the line. And most likely you will accept that as something more or less evident. But it's evident, but on the other hand, it's a little bit curious, because I can move backwards and forwards, and only backwards and forwards, yes, but at the same time, I can move horizontally, vertically, or as I move in the curve, I move horizontally, vertically, and changing my depth. So on one side, it sounds as if I had 1 degree of freedom, 1 ability of movement, backwards and forwards, and on the other hand, it sounds as if I had 3. So it's a little bit of a conundrum, I think you say. It's a little bit of a problem, it's a little bit shocking. Why is that? Why it is actually true that we can move only backwards and forwards? Let's see it. I think we put emphasis on the idea of just moving backwards and forwards in the curve, despite being able to move or moving horizontally, vertically, and in depth, because we say that this line, the path described as I move on this line, is identical to the path I make as I move on this other straight line. And in this line, it's absolutely evident that I can move only backwards and forwards, and only because if I don't move forwards, let's say that this is forwards, or backwards, let's say that this is backwards, I will be going out of the line. So that's the idea we will be working with in order to define or precise our intuition about what degrees of freedom are. I can put it for the case of the line, as you are seeing on your screens. It is true that as I move, I define several parameters. The change on my horizontal, vertical, depth positioning, the turns I am making with respect to an arbitrary north, let's say, blah, 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 blah. But it is true as well that I am defining a value, let's say, which we can call distance from A. Okay, this would be A, and as I move on the line, I am defining a distance. I will be at a distance from A. That's evident. There is no discussion about that. And it is true as well that with that parameter, with the parameter of distance, I can define at which point I am. I mean, there is only one point, which is at a given distance of A and in the line at the same time. Okay, and if I change the value of that parameter, I will be in different points of the line. That's for sure, and that's my degree of freedom, changing my distance to A. Okay, that I change my horizontal and vertical position as I change my distance to A, of course. But the most important parameter here is, let's say, the advancement, the movement, the change in distance. Okay? Why is that? Why is that? It can be seen as with the idea of just putting it like that, of this transformation if you want to, okay, where it's very clear, and it can be shown as well by just means of saying, okay, you are moving on this line. Fantastic. This is A, isn't it? Yes, it is. And you tell me that you are at a distance of 4 units from A and in the line. Yes. So then you have to be on one side on a spherical surface centered on A of radius 4 units and at the same time on the line. And therefore you will be on its intersection on a precise point. Okay, on the intersection of the spherical surface of radius 4 and the line. That's the point where you will be. So you are determined, let's say, by just one parameter. The parameter of the distance you are at from the point A, from the origin of coordinates, let's call it. In a surface, the problem faced will be very similar. Consider a rectangle. We will see that we can move in several directions, okay? In a lot of directions, this direction, this direction, this direction, this direction. So why do we say we move with 2 degrees of freedom? It seems as if we were moving with a ton of degrees of freedom. But the idea remains the same than the one we just explained for the line. Because just now think on the following, okay? When I move, I am changing distances, okay? But I can keep distance and then just change angle. Let's say as if I were moving on the circle that is at this distance from the origin of coordinates, okay? So as I move, I am defining parameters, several parameters, and undeniably, I am defining distance to origin of coordinates and angle with an arbitrary north. Okay, if I am, let's say, here, okay, I am at this distance and with an angle of, let's say, 45 degrees with an arbitrary north. So now we have it. Once again, we are going to repeat the same idea. If we are on a surface, let's say something like this, okay, on a wavy surface, and I am at a given distance of the origin of coordinates, I am on a spherical surface, and therefore I will be on the intersection of the spherical surface and the wavy surface. That's going to give us some kind of wavy circle, let's call it. And then, if you just tell me that you are at a given distance of the of 4 units, let's say, of the origin of coordinates, I can yet move. It's not as if I were in the line. I can yet move. I can yet move changing some kind of angle, okay? An angle with an arbitrary north. And those are your 2 degrees of freedom. There you have them. Distance to origin and angle with arbitrary north, okay? And you won't be able to move without changing those values. You have to or change your distance to the origin of coordinates or change your angle, or you won't be moving. That's on one side. And on the other side, any point on the surface is defined by those 2 values. And that's why we say in a surface you have just 2 degrees of freedom. Okay, so we have finalized with this intuitive, let's say, introduction to the idea of degrees of freedom. Okay, is the freedoms I need to make to get to any point in a shape. If I just have to make one kind of movement, one kind of, if just one parameter defines my positioning on the shape, I have 1 degree of freedom. If I need 2, I am in a shape where there are 2 degrees of freedom. I'm in a surface.